Show by the principle of mathematical induction that for all n belonging to the set of natural numbers n, the expression 4 raised to the power of n plus 15n minus 1 is divisible by 9. Okay, let us begin. Now here in this problem, we do not have to show that the expression is divisible by 9. Rather, we need to show here that for any n value that we take, as long as n is a natural number, this statement is a true statement. That means the expression is always going to be divisible by 9. Now, what we'll do, we are going to consider a statement P of n. So let P of n be the statement which is given by, we have the expression 4 raised to the power of n added to 15n minus 1. So this expression is divisible by, it is divisible by 9. So this is going to be a mathematical statement. We'll need to verify this, that this is true for all n belonging to the set of natural number. For this, first we will consider the natural number 1. So when you consider the natural number 1, then the statement P of 1 is simply going to become 4 raised to the power of 1 added to 15 multiplied to 1 minus 1. So that's going to be equals to, so 4 plus 15, that's 19. 19 minus 1, that's going to be 18. And we know that 18 is indeed divisible by 9. So that means our statement is true for n equals to 9. Or in other words, we can simply say that P of 1 is true. Fine. So P of 1 is true. We'll have to now verify that for other natural numbers, P of n is a true statement. So what we'll do, so we will choose n to be equals to m, such that we will consider the statement P of m is also true. So this is a supposition that we are taking. We are considering P of m to be true. So what is P of m? We only have to rewrite the expression. So we have 4 raised to the power of m added to 15m minus 1. So this expression is divisible by, it is divisible by 9. Now what is m here? So m is a natural number. Okay, so here we are considering this to be a true statement. Okay, let's call this statement number 2. Now, using this statement, our goal will be to prove that the statement P of m plus 1 is also true. So to prove that P of m plus 1 is also a true statement. How do we verify that P of m plus 1 is a true statement? P of m plus 1, such that we'll have to show that 4 raised to the power of m plus 1 added to 15 multiplied to m plus 1 minus 1. This expression is also divisible by 9. So this is what we have to show. So how do we show that this is divisible by 9? So we'll take the help of statement number 2. Now from statement number 2, since we have already considered P of m to be a true statement, where we have stated that 4 raised to the power of m added to 15m minus 1, this is divisible by 9. Now what we can do, we can express it as a multiple of 9. So we'll call it 9 times lambda, where lambda is some natural number. We don't have to worry about the value of lambda. It's simply going to be some natural number. Fine. Now using this, we will try to verify the statement P of m plus 1. Now in the statement number 3 that we have considered, so here we'll consider the statement 4 raised to the power of m plus 1 added to 15 multiplied to m plus 1 minus 1. So we're going to simplify this. So we can rewrite the first term as 4 multiplied to 4 raised to the power of m. All we have done here is use the laws of exponent added to 15 times m added to 15 minus 1. So that's going to be positive 14. This was going to be equals to 4 multiplied to, we have 4 raised to the power of m. So we can take the help of this expression and replace 4 raised to the power of m with 9 lambda plus minus 15m added to 1 plus 15m plus 14. So let's further simplify. We have 4 times 9, that's 36 lambda minus 4 times 15m, so that's going to be 60m, negative 60m added to 4 plus 15m plus 14. So we have 36 lambda minus, so negative 60m plus 15m, so that's going to be negative 45m added to. So 4 plus 4, that's going to be 18. Now we have three terms. Now each of the three terms, from each of the three terms, if we take 9 as the common factor, we have 9 multiplied to 4 lambda minus 5m plus 2. So here we have 9 times beta. So what we have done here is we have replaced 4 lambda minus 5 times m plus 2 with beta. So here we don't have to worry about beta. So what we have shown here that the expression 4m plus 1 added to 15 multiplied to m plus 1 minus 1, this particular expression is a multiple of 9, which means that this is divisible by 9 as well. So this is going to be divisible by 9. So when we say that the expression is divisible by 9, all we have done is we have verified the statement P of m plus 1. So P of m plus 1 is a true statement. If this is a true statement, then we can generalize our statement and say that P of n, the original statement, is going to be true as well, and it is going to be true for all values of n belonging to the set of natural numbers n. That means by using the principle of mathematical induction, we were able to show that for any natural number that we choose, the expression 4 raised to the power of n plus 15n minus 1, this is going to be always divisible by 9, hence proved.